Okay, today we're going to be doing percent of a number. It's a foldable. You need to make sure you're on the same page that I am as we do it. We're going to be using proportions. We're going to start out looking at this word problem. It says a family of 4 uses 343 gallons of water every week for household uses. If the family uses 21% for laundry and cleaning, how many gallons do they use for this purpose? We're going to use proportions, kind of like the one-wazen chart that we did, to solve this percent problem. So we're going to start by writing an equation. When we write an equation, we're going to see that we have this part whole area, and this percent over 100. If you remember, percent means 100. So percent and the percent value and the 100 go together, and then the part and the whole. Just like a fraction is part of a whole, it's going to go together. So when we do this, we fill out what we know. This part right here won't change. No matter how we're doing a proportion equation, we will be using this. So this is an important thing to know. We're going to fill in what we know where we know it. Where we don't know something, the part, we're going to put a variable, an x. Just remember, think about it. It's like a question mark. It's like a box. It's nothing scarier than putting a letter in place of that. We know from our story problem that we have 21% that we see up here in the problem. So we put that there. That's the percent that we know. We know that percent is out of 100. We know that there's a total of 346 gallons that are used, and we need to know what part of it is for the laundry and cleaning. So the way we do this is what's called cross multiply. When we cross multiply, we multiply this way and this way, whichever way you want to think about it. So it makes kind of like an X in the center. So we don't remember when we're multiplying fractions, it's different than this. This is a proportion. Fractions is numerator times numerator, denominator times denominator. This is a proportion, and it's a cross multiplication. It's called the cross products. So when we do that, we get 346 times 21 and 100 times x. And if you wrote this as 100 times x equals 346 times 21, it wouldn't matter. They're equal. Both sides are equivalent to each other. So now we need to do some math. We need to do 346 times 21. So through the magic of my program, we have found that it is 7,266. And when we do this side together, we'll learn more about this, but the number goes in front and the blank, the x, whatever we're trying to find, goes in there. Well, we need to get this x by itself. So what we're going to do is divide each side by 100 because this is a multiplication problem. So we're going to do the opposite. And the opposite of multiplication is division. If we had addition, we would be subtracting, and vice versa. So each side is going to be divided by 100. 100 divided by 100 will just give us that x that we so need by itself. Because once we start hitting this algebra part, we're no longer finding an answer, we're finding a piece of the puzzle. So when we have 7,266 divided by 100, if you do not remember how to divide by 100 by moving the decimal spot, well, do the math. If you remember doing it when we did it with the decimals, when we were moving, when we were doing the metric conversions, that decimal's here, there's 2 zeros. I'm going to move it toward the left since it's getting smaller, and I have 72.66 is what x equals. Well, that's our answer. Right there, 72.66 is what is the usage for laundry and cleaning. So we're going to do some practice problems here. See if I can make this a little bit bigger. Whoops. All right. So it's been a while since I've used this program. I apologize if it's seeming a little rough, but that's what happens. So we have this problem. So I'm going to do this first one with y'all, and then what I'm going to ask you to do is to pause it and then to check it for 2 and 3. Lisa practices free throws every morning. This morning she attempts 50 baskets and makes 84%. How many free throws did she make? So we're having to do, and if you think about it, we have part over whole equals percent over 100. So now we have to figure out what these numbers are. What we know is that she attempted 50 of them. So that is our whole. We know that she made 84%, so that is our percent. We know percent is always over 100. So what we're looking for is how many three throws did she make, so that is our x here. We're going to cross multiply. So we're going to get 100x equals, and I'm going to have to come over here and do this. I don't know that one in my head. 84 times 50, and we get 4,200. So we have to divide each side by 100 because we have multiplication here, so we're going to do the opposite. And we can see that x equals 42 free throws that she made. So she made 42 out of 50. All right, so what I'm going to ask you to do is to pause the video here, try the next one, and then come back and check it. Brandon counted the number of white cars in the parking lot. He counted a total of 81 cars. If there's 180 cars in the parking lot, what percent are white cars? So let's get our thing. We have part over whole equals percent over 100. We know there are 81 white cars. There's a total of 180 cars, and we're looking for what percent. So we have 81 over 180, the part white cars out of the total cars. We don't know what our percent is, but we do know a percent is out of 100. So we can just put an X there. So we're going to cross multiply, and we have 180x equals 8,100. So now we have to divide by 180. So first things first, I'm going to go ahead and cross off 1 0. That just divided it by 10, and it made my number a little bit better. And so now we need to have a division problem. 81 divided by 18. I know that it will go in there about 4 times because I'm taking a pretty decent guess on that. If I don't know, I'm going to do a little problem. 90. Whoops. That's completely wrong. 11, 7. All right. There we go. That looks much better. I know it's the same thing, but I didn't write my simplification there. So if I look at that, that's 17. So I'm thinking if I up that to 5, that might get me right about 90. And it gets me right at 90. Whew. So there, x is equal to 45%. Remember those labels. Labels, labels, labels. Okay, so number 3. During a school assembly, 25% of students wore orange shirts to show school spirits. If 15 students wore orange shirts, how many students attended the assembly? Well, we have 25% and 15 students that wore orange shirts. So remember, we have part over whole equals percent over 100. So We know that 15 students wore it. We know that that is 25%. We know percent is over 100. What we're trying to figure out is our total. By the way, you could put T for total. X is just kind of a default. So if you want to put a different letter, you can, but it really doesn't even make sense. Don't be putting anything just random because you like that letter. So I have 25x equals 1500. I have to divide both sides. Remember, when you write it as a fraction, that means division. We have x equals, let's see, we're going to 15. Let's not do that in my head, and we might make a mistake. So 60. There are a total of 60 students that attended the assembly. Okay, now this section for you guys should be a review because we have done doing percent of a number. So when we do that, remember there are two ways. We can, one, change it to a fraction. Two, change it to a decimal. Honestly, the decimal is the easier way. In your upper grades, you're going to get calculators and you will need to have it in decimal form. So we're going to go ahead and practice this. But I want you to know that you can do it both ways. But in this case, we're going to practice doing it as a decimal. And that way we can also review decimal multiplication again. So a family of four uses 346 gallons of water every week, and if it uses 21% for laundry and cleaning, how many gallons do they use for this purpose? So when we're finding the percent of a number, we're going to write the percent as a decimal and multiply. This is where we could also do it as a fraction, but it really is easier as a decimal. So because if you remember, 21% equals 21 over 100. So when we want to write that as a decimal, all we have to do is move it 2. Now, please notice I don't say move it to the front of the number. You move it 2 to the left. If there's more than 2 digits, it will be between numbers. It's 2 only, 2 to the left, because that stands for each of the zeros in the 100. If there could be, just for example, there could be 320%, and it would just go to that, and it would be 3.2. Okay, now obviously this isn't our problem, but I want you to realize it is 2. Think of the 2 zeros in 100, and that's how many you move it. What we're doing is dividing. If you think of it this way, we're dividing by 100. So when we get here, we need to do the multiplication. So we write the problem. You can put whichever number you think would be easier on the bottom, whichever factor you think, but 21 works pretty well. And we put the decimal there, and then we ignore it and multiply as regular numbers. So when we do this, I like having 1s and 2s on the bottom, except for when I write the number wrong. Let's see if my eraser will work. Okay, for some reason my eraser's not going to work, so I'm just going over it. And then we put our placeholder 0. That would be 12, 9, 6. We have 6, 6, 2, and 7. So that should seem familiar to y'all. 2, 6, 6. Now, we need to account for the decimal there. There are 2 places behind it. If we're ignoring it, it's there, so we're going to move it 2 over, and so I'm going to put it right there. 72 and 66 hundredths. So, is this answer reasonable? Well, the way you figure that out is by estimation. And this helps you know if your number's in a ballpark. So, I would say, and when you estimate, you don't necessarily have to use the rules of rounding specifically. I can estimate down if it makes a better estimate for me. I can estimate up if it makes a better estimate for me. I would, by the way, this means about equal to. It's about equal to 350, and I would estimate this to be 20. And so I know that when I estimate this, that's goofy decimal, it would be about 70. So that is about what we had. So sometimes people estimate beforehand, sometimes they estimate afterwards, but since 72 and 6600 is close to 70, the answer is reasonable. That means it makes sense. It could conceivably happen. All right, so now we're going to do the practice again. We're going to do the first one together, and then again, I'm going to ask you to pause. If you really need it worked out with you, that's fine, but try and test yourself and practice this. Lindsay ate dinner at Olive Garden. The dinner cost was $25.50. If she wants to leave a 20% tip, how much will she leave for the tip? So what we have is we're trying to find out what 20% of 2550 is. Whenever you see that word of, we know that that is multiplication. So there's actually a couple of ways to do this. Remember, there is more than one way to get to HEB at this point. So 20% we know is 20 over 100, which is 0.20. I do not have to leave that 0 there. I can cross it off. So I have 2550. Again, I could also leave that 0 off. And I'm going to multiply it by 0.2. I'm going to just cross those off. We don't need them. If we don't need them, we're not going to worry about them. That would be 10, 11, 5. There are two numbers because I ignored those behind. And so the tip is $5.10. So what they like to do is say if the bill was $25.50 and she leaves $5.10, this isn't what it's asking, but they will do this to you. How much was the total bill? And it would be $30 because remember, it is added on. So the other way to do this is to use, this is the way I was always taught to figure it out, is to use the 10% rule. If I have $25.50 and I want to know what 10% of a number is, I move that decimal spot 1. So $25.50, 10% is equal to $2.55. So if I wanted 20%, I would, because 10% plus 10% would be 20%, I would add another one on. So this is one of those mental math tricks. You definitely need to know how to do it this way, but this way is also good too. It lets you know if it is reasonable. But remember, when you add, your decimals do have to be in alignment. And again, we get the same cost. But this, knowing what 10% of a number is of a total, just by moving that decimal over one spot because there's 1 0, is a mental math trick that would help you get this. So if I wanted 30%, I could add on another $2.50. If I wanted 50%, and etc. So I hope you kind of pay attention to that. I would also suggest that you try figuring out the tips when you go to the restaurants with your parents. So go ahead and pause it, and then we'll do these next ones. All right, Miss Louisa deposits 25% of her weekly earnings into her savings account. If she earns $850 this week, how much money will she deposit in her savings? So what we're looking for is 25% of 850. So 25% is equal to 0.25 of is times 850. So they don't both end in zeros, so I can't drop that 0. I need to keep it. I just need to come do the math. And so we'll have 0.25. Oops. I was getting ahead of myself there. I always X that one just so that when I have a situation like this where I'm multiplying that, I know that I'm doing it correctly. You don't have to do it that way, but, you know, occasionally I know what I'm talking about. Okay, so there's two numbers behind it. So I'm getting $212.50 is what 25% of her savings. So we can do this a couple of ways. We could also use that chart that we have where we know that the whole is 850 and we know that she wants 25% over 100. We could do it this way. We could do where we know what 10% is. So here's one way. Here's two way. Here's the third way. 10% of 850. I would move my decimal over 1. So it would be 85. And then I could do that a second time. Plus 85. 0, 17. And then I would need to know what half of 85 is. And so that would be 42.5. And then when I add them, oops, I'm kind of writing all over it, but I get the same number. So you can use this cross multiplication. You can do where you're just straight multiplying it. You can do your estimation, 10%, and then go from there. There's lots of ways to get there. So Ray bought a pair of boots for $75. The sales tax is 8%. What was the total for the boots? So what we need to know is what is 85% of 75. So if we were writing this as a decimal, remember it's out of 100. So sometimes it's easier to do the 8 over 100. And the total of the boots was 75. And we need to know what part of that. So we can put X there. Sometimes it's easier to do it this way. If you're doing it as a decimal, it's 0.08 times 75. You have to remember it's 800. So when you write that 8, it needs to go in the 100 spot. You need to put that placeholder 0. So if we do it this way, and you can't drop that 0, 56 plus 4 would be 6, 2. So it would be $6. Let's see if we get the same thing this way. We have 100x equals, and then we divide each side by 100, and we get x equals 6. So we get the same thing, but have we answered the question? Let's go back and check. What was the total for the boots? If you remember when we were doing the diagrams, we know our boots are 75. The tax gets added on. So we need to have the 75 plus the $6. The total cost is the $81. Remember, money goes to the 100 spot. This is the total cost. All right, kiddos, you have some word problems to do. You can review this video as you need it. This page will be folded and put in your interactive notebook. Toodle doodles. And that's not dismissing. That's do your homework toodle doodles. Bye.